Okay, so the last section for elimination is talking about word problems and writing a system from a word problem and then solving it using elimination. I think we did this with substitution as well. So you should have some idea of how it works, but it's difficult. You guys read through the problem, write the equations, and then solve them. So I can understand if it seems hard, but really the best way to get good at it is just to practice. So let's look at the first example here. It says the sum of two numbers is 27. Their difference is 9. Write a system and solve. So each sentence here gives you an equation. The sum of two numbers is 27. Well, sum is plus, and difference is minus. So we know that two numbers that we don't know, if you add them together, we get 27, and if you subtract them, we get 9. So the first equation is just x plus y. Those are our two numbers. Plus, because it's a sum, so x plus y equals 27. And for the difference, that's minus. So x minus y equals 9. And now we have to solve. And if you look, you can see that our equations are already set up for elimination because we have a positive y and a negative y. So add these two equations together, and the x plus x is 2x. The y's cancel out, and 2x equals 36. Divide by 2, and x equals 18. So one of our numbers is 18. We still need y though. So use that first equation. You could use either one, but this one's a little easier. 18 plus y equals 27. So subtract 18, and y equals 9. So the answer to our problem, x is 18, y equals 9. There are our two numbers. Now when you have word problems, you usually will write your answer like this. You won't write it as an ordered pair. You'll have to say like, this number is this, and because a lot of times you'll see on the next example too, it's like shirts and hats instead of just numbers. So usually you'll write out your solution. Let's go to that one, by the way. Leo bought 5 shirts and 2 hats for $45. Devin bought 1 shirt and 3 hats for $35. Those are your two equations. Right there. Write a system and solve. We're trying to find the cost of each shirt and each hat. So let's go ahead and make shirts x and hats y, and they'll be that for both equations. So let's go ahead. 5 shirts and 2 hats. So 5x plus 2y, right? 5 shirts and 2 hats equals 45 for $45. Now Devin bought 1 shirt, so 1x plus 3 hats, so 3y equals $35. So it's kind of like you've got an equation here for Leo and an equation here for Devin. Right? They each get an equation. And now we have to solve. And because we're practicing elimination, I'll multiply this equation here by -5. This equation would also be simple to use substitution if you subtract 3y. But we're looking at elimination, so we'll use that method. So 5x plus 2y equals 45, and then for our second one, after we changed it, we get -5x minus 15y equals -135. Wait, let me make sure. No, not -135. 175. I think I got a little ahead of myself there. Okay, so now we can add these together. So the x's cancel. We get -13y equals, now here's your -135. Nope, sorry, -130. And then you divide by -13. And y equals 10. So we know that each hat is $10. We can go ahead and write that in our solution. We still need x. So I would maybe use that second equation, x plus 3y equals 35, because x is all by itself. So we're going to put 10 in for y, because we know that y equals 10. So x plus 30 equals 35. So subtract 30, and we know that x equals 5. So if hats are $10, that means that each shirt is $5. And there's your solution for the second one. So again, we could write our solution as an ordered pair, but because it's asking you to find the cost of each shirt and each hat, you might want to write your answer in a different way. So the remainder of this practice, you've got basically the same two problems, a sum and difference problem and then a shopping problem. And they're set up pretty similarly, so you should be able to just kind of follow the steps and try each problem. So two questions to finish on this one.